Hello everybody and welcome to the Physics Corner, a series where we solve simple physics introductory problems. I am your host, Dr. Christopher Sorolla. Today we are solving the case of a man trying to swing across a vine in the jungle. Let's go ahead and take a look. So, the problem is this. An explorer runs through the jungle and sees a pit in the distance. The explorer grabs onto a vine to swing across. Our question is this: is the vine strong enough to hold on to the explorer, given the facts that we present to you in the question? So, what we do, of course, is we always list our knowns and our unknown quantities to go along with our problem and our picture. So the knowns are this: the mass of our explorer is 75 kilograms. We will assume that the acceleration of gravity, little g, is exactly 10 meters per second squared, like we usually do to round off. We'll also assume that the length of the vine is 10 meters. The maximum speed at which the explorer reaches during his swing is going to be 10 meters per second. We'll tell you about that in just a moment. And the braking strain, or the braking strength, if you will, of the vine will be 1,600 newtons. What we do not know is the acceleration of the explorer during his swing and the maximum tension that he will exert during his swing. Let's go ahead and find out. First off, although it doesn't necessarily look at first glance like this might be the case, this is a rotational motion or centripetal motion problem. Why? Because when the explorer swings in the vine, the explorer will be going in an arc of a circle. It's not necessary to go in a complete arc or a complete circle. An arc of a circle, a piece of circle is just fine. And while you're doing that, or while our explorer is doing that, he will be experiencing centripetal motion. More to the point, the direction of the acceleration of the motion, in this case, will be upwards towards the point of the vine that's connected to a tree somewhere above him. So the direction of the centripetal acceleration will be pointing up, or more or less. And we're going to pick a specific spot at which to have that happen. All right, so the way to set this up is with a free body diagram. So let's go ahead and sketch one out. So free body diagram will look like this. Mass of our explorer, put that right here. Now, we're going to assume or take a look at the force when the explorer is exactly vertical. That is, when the vine is sticking straight down. Why are we going to look at that? Because that, it turns out, is when we'll have the maximum amount of force applied. At any other point, the explorer's centripetal acceleration will be off at an angle compared to the direction of the tension and won't hit a maximum. So, if we want to reach a maximum amount of force exerted on the vine, we want the explorer to be at that point straight down, or, if you will, at the bottom of his swing, which means tension, in this case, will be pointing straight up, and as always, the force of gravity, mg, will be pointing straight downwards, like that. And that's it. That's it for our forces in this particular picture. We're going to assume that other forces, like, say, friction, air drag, those things will be either non-existent or irrelevant or negligible, as we like to say. And so we can just simply assume that these are the only two forces that make a difference for our problem. Now, one more thing. Let's assume a direction going upward as positive when we set up our problem. This will come in handy, not only because, of course, tension is going up and weight's going down then, but also because the direction of our centripetal acceleration will then be positive. Remember, it is going along the length of this vine towards the center of the circle or arc of the circle, and that will be pointing upwards. Right, so let's go ahead and do our solution. So the net force, or sums of forces, is what? Well, tension going upwards, right? And weight of our explorer going downwards. And that is it. There's no other forces to worry about, okay? So don't forget our second important step then. We set these equal to the mass times acceleration of the explorer. So with those choices of our directions, we can set up our equation. Now, in this particular equation, we know the mass of the explorer, we know little g. We do not know yet the centripetal acceleration or the tension, which is, of course, what we're trying to find ultimately. So you could do this one of two ways. You could just simply do a solution for the problem and set up that way. But I think in this particular case, it'd be more instructive to solve for the acceleration directly. So let's go ahead and do that. So centripetal acceleration's formula is square of speed divided by radius of your circle, like that. Okay. And we do have the numbers to solve it, so let's do that. So the speed was 10 meters per second. Now again, maximum speed, which is at the bottom of the swing, that's what we want, divided by the 10 meters in length of the rope. And by the way, if you're wondering what 10 meters works out to be, it's about 34 feet in English units. So it gives you kind of a feel for how long that rope might be, which is long, but not uncharacteristically too long. Okay. Well, let's see here. 10 squared is 100 divided by 10. No, that's simple. That's 10. All right. Check your units. If you look carefully, meters squared divided by meters gives me a meter. Per second squared, per second squared. So we do have the correct units for our acceleration. Now, next step is to take this equation here and solve for tension. So let's bring the equation down over this way. So I'll just rewrite it here so you can see what we're doing. Like that. Now, you don't have to write this extra bit here, but I did anyway. Okay, so this piece is what we're interested in right there. Let's solve for tension. So if I look at this, I have to add the weight to both sides. So there'll be mg plus ma now on the right-hand side. If I add it to the left, of course, mg cancels. If I add it to the right, then I have mg. And I can further simplify this if I want to by dragging the m out of it because it's common to both of those terms. And it looks like this. Okay. Now it's time to put in some numbers. So tension equals mass was 75 kilograms. Little g is 10 meters per second squared. And I chose the numbers to work out this way for simplicity. 10 meters per second squared for the acceleration. Okay, of course that's 75 kilograms then multiplied by 20 meters per second squared, right? And you could double check me on this. 75 times 20 is 1,500, or if you prefer, 1,500 newtons. So that is the tension, the maximum tension specifically, that our explorer exerts on the vine. Last question, does the explorer make it across? And well, as I can see from these numbers, 1,500 newtons is in fact less than the 1,600 newtons that we had. So yes, our explorer makes it. All right, folks, thank you very much for your attention. As always, these videos are supported in part by the University of Mississippi and University of Southern Mississippi. The video was recorded in Hattiesburg, Mississippi. Technical assistance is provided by Sydney Galtraw and Sophia Turner. Again, I am Dr. Christopher Cirola. Thank you all for your attention, and we'll see you next time. Clear skies.